In this video, we will see the further problems from the exercise 6.5. Question number 4. Show that the lines given by this Cartesian equation and this Cartesian equations intersect. Also find the point of intersection. So we are given two equations. We need to show whether they intersect, and also we need to find the point of intersection. To show that these two lines intersect, then let's start defining. So let's take the first line and let's jot that down here. X minus 3 by 3 is equal to y minus 3 by minus 1 is equal to z minus 1 is equal to 0. This implies that our z is equal to 1. And the second equation, x minus 6 by 2 is equal to z minus 1 by 3 and y minus 2 is equal to 0. This implies here that y is equal to 2. So, if we are going to define them with the point and the direction ratios, our x1, y1 and z1 is 3, 3 and 1 for the first equation. And for the second equation, let's call them as x2, y2 and z2 is 6, 2 and 1. Further, our b1, b2, b3, which is the direction ratios, is 3, minus 1 and 0. And here the direction ratios can be defined as d1, d2, d3 is 2, 0 and 3. Now, the condition for two lines to intersect is that x2 minus x1, y2 minus y1, z2 minus z1, then b1, b2, b3, then d1, d2, d3 is equal to 0. So let's substitute the values of x2, x1, b1, d1 and all these values into this determinant. So our x2 minus x1, which is 6 minus 3, will be 3. y2 minus y1 will be 2 minus 3, which is minus 1. Then it's 0. Then our b1, b2, b3 is 3 minus 1 and 0. Our d1, d2, d3 is 2, 0 and 3. Now this is obviously equal to 0 because these two rows are equal. Since our R1 and R2 are equal. Okay. Therefore, the two lines are intersecting lines. Now for the second part of the question. Now since the two lines intersect, at some point the xyz of the first equation is equal to the xyz of the second equation. So let's define the first equation as x minus 3 by 3, which is equal to y minus 3 by minus 1 is equal to, let's say, some lambda. And we know that in the first equation our z is equal to 1. Then in the second equation we can also say x minus 6 by 2 is equal to z minus 1 by 3 is equal to, let's say, mu, and our y is equal to 2 here. So equating the values of x, y and z, we can say that x is equal to 3 lambda plus 3. So 3 lambda plus 3 is the point x. Similarly, y is equal to minus lambda plus 3. So minus lambda plus 3, and our z is 1. So this is the point, and here we can write the point as 2 mu plus 6 comma 2, which is the value of y here, then 3 mu plus 1. Now equating these two, these are nothing but the coefficients of I cap, j cap and k cap. Similarly for here. So equating the two, our minus lambda plus 3 is equal to 2. So let's put that value here. Minus lambda plus 3 is equal to 2, which implies our lambda is equal to 3 minus 2, which is 1. Similarly, we can say that 3 mu plus 1 is equal to 1. So 3 mu plus 1 is equal to 1. Therefore, mu is equal to 0. So we have lambda and mu. So substituting the value onto the point here, let's say mu 0. So if you substitute this value, you will get 6, 2 and 1. So the point of intersection is 6, 2 and 1. That's the answer. Question number 5. Show that the straight lines x plus 1 is equal to 2y is equal to minus 12z and x is equal to y plus 2 is equal to 6z minus 6 are skewed, and hence find the shortest distance between them. So the methodology that we would follow here is, we need to first show that they are skew lines, and second we have to find the shortest distance. So for the first factor, which is the skew lines, rewrite the equations in the parametric form a plus s b vector and c plus td vector. Once you rewrite them, then if we show that the scalar triple product c minus a b d is not equal to 0, then it's a skew line. All right. So this is the condition. So after we prove this, then what we need to do is to find the shortest distance, we apply the formula d is equal to the absolute value of the scalar triple product c minus c vector minus a vector, b and d, the absolute value divided by b cross product with d. So if we find this value, then we find the answer to our problem. So let's proceed. So let's first rewrite the equations in the proper Cartesian form. So we are given x plus 1 is equal to 2y is equal to minus 12z. So this can be rewritten as x plus 1 is equal to y by 1 by 2 is equal to z over minus 1 by 12. Similarly, the second equation, which is x is equal to y plus 2 is equal to 6z minus 6. This can be rewritten as x is equal to y plus 2 is equal to the z factor will be z minus 1 divided by 1 by 6. Taking 6 as a common multiple and then bringing it to the denominator, you get z minus 1 by 1 by 6. So these are our two new lines. So here our x1, y1, z1 will be equal to 1, 0 and 0, and our direction ratios here will be b1, b2, b3 is 1, 1 by 2 and minus 1 by 12. Similarly, for this equation, our x2, y2, z2 is equal to 0, minus 2 and 1. And our direction ratios d1, d2, d3 is equal to 1, 1 and 1 by 6. Alright, now the condition for skew lines is given by the skew lines is for x2 minus x1, y2 minus y1 and z2 minus z1. Then we have b1, b2, b3, d1, d2 and d3. This is not equal to 0. Or you can also call this as our scalar triple product, which is c vector minus a vector, b vector, d vector is not equal to 0. Alright, so let's substitute the values onto the determinant here. So this determinant, which is the same as this, or c minus a, b, d is equal to, substituting the values of x2 minus x1. 0 minus the x1 should be minus 1 here. So 0 minus of minus 1 will be plus 1. Similarly, we have a y2 minus y1 as minus 2 and z2 minus z1 is 1. b1, b2, b3 are 1, 1 by 2 and minus 1 by 12. And d1, d2, d3 are 1, 1 and 1 by 6. So simplifying this, 1 into 1 by 6 into 1 by 2 will be 1 by 12, minus into minus plus 1 by 12, minus into minus 2 will be plus 2 times 1 into 1 by 6 is 1 by 6, minus into minus is plus 1 by 12 plus 1 times 1 minus 1 by 2. 2 by 12 plus 2 times of 12 as the denominator, then it's 3 plus 1 by 2. Further simplifying this, this is 1 by 6, 1 by 6 here. So keeping 6 as the denominator, 1 plus 3 plus 3, our answer is 7 by 6. Therefore, our C minus A, B, D, the scalar triple product, is not equal to 0. Therefore, the lines are skew lines. So that takes care of the first part of the question. Now for the second part of the question, which is to find the shortest distance, we need to find the vector cross product of B with D, and this is defined as I cap, j cap, k cap, and our B1, B2, B3 are 1, 1 by 2, and minus 1 by 12. And our D1, D2, D3 are 1, 1, and 1 by 6. So, solving this, we get our I cap into 1 by 12 plus 1 by 12 plus j cap into 1 by 6 plus 1 by 12 plus k cap into 1 minus 1 by 2. So this is nothing but 2 by 12, which is 1 by 6 I cap. So 1 by 6 I cap, and the coefficient of j cap would be 3 by 12, which is 1 by 4. So plus 1 by 4 j cap plus half of k cap, half k cap. Further, the magnitude of B vector cross product with D vector is equal to square root of 1 by 6 squared plus 1 by 4 squared plus 1 by 2 squared, which is equal to 1 by 36 plus 1 by 16 plus 1 by 4. Further, solving this, we get 196 over 576. This is equal to 7 by 12. Now the shortest distance between the skew lines is equal to the absolute value of C, the scalar triple product, B, D, divided by the magnitude of B cross product with D, which is equal to, this is 7 by 6 here, so 7 by 6 over 7 by 12. So simplifying this, 7 by 6 into 12 by 7, which is equal to 2 units. That's the answer. Question number 6. Find the parametric form of vector equation of the straight line passing through -1, 2, 1 and parallel to the straight line given by this equation, and hence find the shortest distance between these two lines. So first our objective is to find this line. Okay, to find this line, so let us say let R is equal to A plus TB, okay, be the straight line, you can say required, which is the required straight line. So here our A vector is given as, using this point, we can call it minus I cap plus 2 j cap plus k cap, and our b vector will be this vector here because it's parallel to this straight line. So I cap minus 2j cap plus k cap. So we have the required line as the parametric form of the required line is or is equal to, our point is minus I cap plus 2j cap plus k cap plus t times I cap minus 2j cap plus k cap. The second line is of the form or is equal to c vector plus sd vector. Therefore, which implies our c vector is equal to 2i cap plus 3j cap minus k cap. So vector c minus vector a is 2 minus of minus 1, so it's plus 1, so it's 3 I cap plus j cap minus 2 k cap. Next we need to find c minus a cross product with vector b, which will be given by the determinant I cap, j cap, k cap. Our vector CA was coefficients is 3, 1, minus 2, and vector B coefficients are 1, minus 2, and 1. So that's the determinant. So solving this further, we get I cap into 1 plus 4, it's minus, then it's minus j cap into 3, minus of minus 2 will be plus 2, plus k cap into minus 6 minus 1. So that's equal to minus 3 I cap minus 5 j cap minus 7 k cap. Therefore, the magnitude of this vector, which is c minus a cross product with b, is equal to square root of minus 3 squared plus minus 5 squared plus minus 7 squared. So that's equal to 9 plus 25 plus 49, which is equal to square root of 83. Similarly, the magnitude of vector b is equal to root of 1 squared plus 2 squared plus 1 squared, that's equal to root of 6. So our shortest distance between parallel lines is equal to the magnitude of the vector c minus a cross product with vector b divided by the magnitude of b. So this is given as root of 83 over square root of 6 units. That's our answer. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.